Hello and welcome back to Anton Math. Now in this video we're going to talk about Pascal's triangle. And we're going to derive it using Pascal's identity that we talked about in the last video. So recall that Pascal's identity was that S choose K is equal to S minus 1 choose K plus S minus 1 choose K minus 1. Now what Pascal's triangle is it's this arrangement, this triangle-like array of all of these choice functions, or all of these binomial coefficients, in this way. I take all of them where my S is 0, and that's my first row. Then I take all where my S is, where my S is 1, and that's the second row. Then I take all where my S is 2, that's my third row, and continue on in this fashion. Now I offset the rows a little bit so that they're all centered, like around the central vertex of this triangle. This is 3, 3, 0, 3, 1, 3, 2, 3, 3, and so on. Now with this identity, what we see is that any of these choice functions are going to be the sum of two other choice functions, and the two choice functions that they're the sum of are on the row above them, and they're going to be centered above them, so one to the left and one to the right. Right? Here I have 2 choose 1, that's going to be equal to 1 choose 0 plus 1 choose 1 by my Pascal's identity here. 1 choose 0 is 0 choose 0 plus 0 choose negative 1, which is just 0. Right? And over here we have this same result, and this happens all over this Pascal's triangle, where if we want to find the next row of the Pascal's triangle, we're just adding two consecutive elements together to get the element in the row below it that's centered between those two elements. Right? So this is kind of the additive structure of the Pascal's triangle. So let's look at the first couple of rows, and the way that we use the Pascal's triangle, at least for this course and in this context, is if we want to very quickly calculate out an entire row of these choice functions, or an entire row of binomial coefficients. So I know that 0 choose 0 is just 1. So if using our additive structure, I'm adding, to get these next ones, I'm just adding 1 and 0 to get this one, and 1 and 0 over here to get this one. Now for my next row, 1 plus 0 is 1, 1 plus 1 is 2, and 1 plus 0 is 1. For my third row, 1 plus 0 is 1, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 0 is 3. For my fourth row, 0 plus 1 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1 plus 0 is 0, and I'll do the fifth and sixth row here quickly. 1, 5, 10, 10, 5, 1, and 1, 6, 15, 20, 15, 6, 1. Now we can also see the symmetric property very cleanly here, right? For example, this right here, this is 4 choose 1, and this right here, this is 4 choose 3. Or in other words, this is 4 choose 4 minus 1. Right? Remember, our property 4 choose k is the same as 4 choose 4 minus k. Right? And that's what we have right here. Now Pascal's triangle is going to be useful especially when you need to calculate multiple coefficients. So if you need to know all the coefficients for a particular set of size s, or in other words, let's say you want to know how many different power sets there are of a set of size 5. Well, that's just going to be all of these, right? This is how many subsets there are of size 1, or sorry, of size 0. This is how many subsets there are of size 1, of size 2, of size 3, of size 4, and of size 5. So if we add all of these together, we're going to get 2 to the 5, or 32. There's going to be 32 possible subsets from a set of size 5. Right? This gives me, each of these coefficients gives me the number of subsets there are of a particular size. So if I add them all together, I'm going to get all of the possible subsets. Now this is going to be even more useful when we get to the binomial theorem, as we see when we get there. But since we're covering Pascal's identity in this section, I wanted to introduce this triangle, and it will become very useful later. Now in the next video I'm just going to do a bunch of worked examples using our permutation and selection functions that we've been talking about so far. And again, they'll be word problem type examples. Those are the examples that you would usually see or that you would usually want to use this material to solve. So we'll see you in the next video.